Now, let us discuss the principles of hydrostatics. Imagine this is your object, and you applied a force in your object. And this is the cross-sectional area of your object. And cross-sectional area A. Pressure P is equal to the force applied to the cross-sectional area of your object. So that is pressure. If the unit of force is in kilonewton and the unit of area is in meter squared, the corresponding value is expressed in kilopascal, wherein Pascal is equal to Newton per meter squared. According to Pascal, or the famous Pascal's law, at any point in a fluid at rest, the pressure is the same in all directions. So, imagine this is you. And you are submerged in a water at rest. Can you feel the pressure exerted by the water to you is equal in all directions? Can you feel that pressure when you are under the water? So that explains Pascal's law. At any point in a fluid at rest, take note that the fluid must be at rest. The pressure you feel when you are under the water is the same in all directions. So, here, the pressure P is equal to the force over the area in which it is applied, or also equal to the unit weight of the water or the fluid times the height. So here in our figure, the unit weight is equal to the unit weight of the water, and the height is from the surface of the water to the center of gravity of your body. So that will be the computation for the pressure when you are submerged in a fluid. There are three kinds of pressure. We have the atmospheric pressure, or P atmospheric. It is the pressure caused by the atmosphere. So here we cannot differentiate the atmospheric pressure because the atmospheric pressure is almost the same in the ground surface, but when you try to travel to another planet, you will see that the pressure is different, or perhaps in the moon. And then the gauge pressure, or the P gauge here. It is the additional pressure in the system relative to the atmospheric pressure. So the gauge pressure is relative to the atmospheric pressure. And then the last is the absolute pressure. Absolute pressure is the total pressure. So meaning, if it is the total pressure, then the P gauge plus the P atmospheric, or the atmospheric pressure, is equal to the absolute pressure. Let us now discuss the hydrostatic forces, or the force exerted by the fluid or the water to your object when it is submerged. So the hydrostatic force is equal to the area of your object, cross-sectional area of your object, multiplied by the unit weight of your fluid times the bar age, or the bar age is the distance from the surface of the water to the center of gravity. So take note that H is a vertical distance from the surface of the water up to the center of the gravity of your object. So let us recall from Pascal's law that he states that at any point in a fluid at rest, the pressure is the same in all directions. From that statement, we may say that the pressure distribution in this gate in our example, submerged in a water, is the same in all directions. So from the previous formula, that the pressure P is equal to the force applied over the cross-sectional, the area of your object. If we cross-multiply this equation, we will get that the force is equal to the pressure times the cross-sectional area. Now, the pressure exerted by the fluid at rest is equal to unit weight times the bar H. This is now the pressure times the cross-sectional area. Take note that the H is the distance, is a vertical distance from the surface of water to the center of gravity. Therefore, F is now equal to unit weight of your fluid times bar H. The cross-sectional area is width times the length. So width times the length. So here is our formula. And from the definition, the hydrostatic force is the pressure felt by your object in its centroid multiplied by the cross-sectional area. And that pressure at the centroid is equal to this unit weight times the bar H. Now, from the figure, we have the variable E. E is the eccentricity. It is the distance from the force F, or the point of application of the force, to the center of gravity. So meaning, if the force is applied to the center of gravity, the eccentricity is equal to 0. So in our figure, to compute the eccentricity E, the formula that we will use is this: unit weight times the I, or the moment of inertia, times sine theta, over the hydrostatic force F. Theta here in our figure is the inclination of our object with respect to the horizontal. Or we may use also the formula E is equal to the gross moment, the moment of inertia, times the cross-sectional area, times the bar Y. Bar Y is the distance from bar Y, here is a bar Y, is the distance from the center of gravity parallel to the inclination of your object up to the surface of your fluid. So the difference between bar Y and bar H. Bar Y is parallel to the inclination of your object, while bar H is the vertical distance. So that will be the formula that we will use in hydrostatic forces. Now, let us discuss about the hydrostatic forces acting on curved surfaces. So, if we imagine that this is your... If we imagine that this is your gate here, this is your gate, it is a curved surface, and then the hydrostatic or the water or the fluid that exerts pressure on your gate is a water here, and it is a curved surface. It has a radius r. So the hydrostatic force P hydrostatic force P is equal to the square root of the component or the horizontal component of the hydrostatic force squared plus the square of the vertical component of the hydrostatic force. Now, the horizontal component of the hydrostatic force acting on the curved surface is equal to the unit weight of the fluid times the bar age, or the distance from the surface of your fluid to the center of gravity of your surface or your object times the cross-sectional area. So if we project the cross-sectional area of this gate, it will be just like a simple, just like that. But it is only curved. And then the vertical component of the hydrostatic force is equal to the weight of the fluid acting on the surface. So it is just weight of the fluid. So the weight of the fluid acting on it is just the unit weight of the fluid multiplied by the volume. And here, so the volume that we will consider here is the one shaded in green. And here we will consider this volume because of the displaced liquid. It will now exert a force equivalent to that displaced liquid. So that will be our vertical component of your hydrostatic force. And the distance x, if you are wondering, if we consider this as a quartile circle, then we can say that the distance x is equal to 4r over 3I.
Thank you for listening for our short discussion. So for queries, you can comment your questions or you can message me directly on my contacts that I gave you. I will upload a copy of this presentation or a PDF of the lectures on one of our classroom accounts. And yeah, that's all. Thank you. See you next time.